I think so. Okay. So to introduce the idea of what we're solving today, I'm going to use these two equations. This is the one that we're learning today. This is review. Okay, let's go ahead and graph it first. So to solve this, we could graph y equals sine, and we could graph y equals a half. Where they intersect are my solutions. So I know sine goes up to 1, down to -1, period's 2 pi. It's going up through the origin. So up, down halfway, and back up. Okay. I know that the graph of y equals 1/2 looks like this. I'm doing degrees, so let me change this to 360 degrees. Okay, so it appears I have two solutions, and those are what I'm solving for. If I take this original equation and I convert it to an inverse, sine inverse of a half equals x, the calculator is only going to give me one answer. What answer is that in degrees? That one right there, what is it?
45 degrees.
I heard several different answers. Which one's correct? In degrees. Yeah.
Yeah, 45 degrees.
45 degrees, sine doesn't equal a half at 45
You
degrees.
see here.
30.
It's either 30 or 60, I don't know which one it is.
30.
Okay, let's check. So, if you think it might be a 30, just draw a quick triangle. So 1, 2, 3, 3. If this is 30, sine is opposite over hypotenuse, so yes, it's 30. So the calculator is going to say x equals 30 degrees. But we know there's two answers from the graph. Calculator only gives us one because the range of sine inverse is -90 to 90. So we have to find the second angle on our own, which is 150. How do you know?
Because it's like rotating.
Okay, good. So if you think about it with the circle, these two have the same reference angle. They're going to have the same opposite sides and the same hypotenuses. So yes, this angle over here would be from 0 over to there would be 150. Okay. So you'll notice I kind of use two different graphs to illustrate this, right? One where I'm graphing sine and a half, and another one where I'm looking at the circle, where my degrees are rotating around, and I'm looking at the opposite side and their radius, or the y-value radius. Both of these help me see there's going to be two answers between 0 and 360. Okay, any questions about that? That was all review. Josh?
There's only two answers.
There are only two answers.
Okay.
Yep. Because anywhere else on the circle, like if I went down here, it's going to be -1/2.
And then it just repeats.
Yes, it does repeat, so that's why I have this restriction. Okay, so this one's very closely related. Let's go ahead and do the same strategy. So what would be different about graphing sine of 2x versus graphing sine? What happens to the graph?
Shrinks.
Shrinks which way? Horizontally or vertically?
Horizontally.
Horizontally. Okay. So what does that mean? What's the new period going to be on this one?
Still one in variable?
That's the amplitude. Periods left and right. When is it going to repeat? What angle?
Pi.
Okay, but in degrees?
Oh, 180.
Right. So if I keep the same scale I had over there, about like this time it's going to be repeating at 180. So it's going to be compressed horizontally and look more like this. Something like that. Okay, and if I graph y equals a half, that's something like this. And now between 0 and 360, I have 1, 2, 3, 4 answers. Right?
Mm-hmm.
So I should have 4 answers. Look again at my equations. The only difference is a 2x here instead of an x. Okay, so we start off solving the same way. We can do sine inverse of 1/2. It's exactly the same as what we did there. The calculator is going to say x is 30 degrees. Huh?
Is it 15?
It is. Yeah. Oh, sorry. I forgot. This is incorrect. When I do sine inverse of a half, I should be getting 2x, right? So 2x is 30. Okay, but it can also equal any full rotation and 30. So in other words, I could add 360 into this. So for example, if n is 1, wouldn't 390 have a sine of a half also? 360 plus another 30?
Yeah.
Okay, so why didn't I do that over here?
Because restriction.
Right, over here if I had added 360, I would be beyond, 390 is beyond. Okay, but isn't 390 beyond here also?
Yeah.
So it kind of is. The thing is, this is 2x. If 2x equals 390, if 2x is 390, is x between 0 and 360? It would be, right?
195 or something?
Yeah. So think about this. If x is between 0 and 360, what's 2x have to be between?
0 and 720.
Yeah. So as long as 390 is less than 720, it's going to be okay. Right? Okay. So thinking about the circle again, just think about one revolution. Remember, I have another answer. That's 150. So 2x could also equal 150 plus any full rotation. Are we comfortable so far? Okay, so I'm just going to solve for x. Divide by 2. So 15 degrees plus 180 n. N is just an integer. 75 degrees plus 180 n. N is again an integer. So I just switched from 2x to x, which means now I'm back to this restriction. So now I'll just write down every angle that works. So
it's number 4, right?
So I could let n be 0, which would give me 15 degrees. I could let n be 1, which would be 180 plus 15, 195 degrees. I could let n be 2, but that'd give me 360 plus 15, which is past where I need to be. Don't forget to be taking notes on this, right? Okay, and Sarah, what would I put here? I could let n be 0.
It could be 75. It could be 360 plus 180, which is
180 plus 75.
oh
255.
yeah.
If I let n be 2, I would have 360 plus 75, which is past my range. So these are my 4 answers. Okay. So that's an intro to what we're doing. If you follow this strategy, what we just did here, so find your two angles between 0 and 360, add multiples of 360, then go ahead and solve for x, and then write down every angle that works. That will work every time. Any questions on what we did? Okay. So over here, let's talk about one more thing. Over here, it made sense that we just had 2 answers, right? Because one in the first quadrant, one in the second. How does it make sense to have 4 answers over here, though? If we think about if we think about kind of the circular functions, how does it make sense that we have 4 answers? Well, when x is 15, right, so right here, when x is 15, don't forget, we're doing sine of 2x. So in other words, sine of 30 is going to give me a half. So that one works. What if I went all the way around the whole circle, 360 plus another 15? Okay, sorry, no, let's go to 195. if I was at 195, so that's 15 past right here. But don't forget, again, we're doing sine of 2x. What's 2 times 195?
I mean, 390.
390, which is 360 plus 30. So what's sine of 30? A half. So these two angles really represent a 30-degree angle, right? It's just that we're doubling them, right? So both of these, once we double them, are giving me a sine of 30, which is a half. These two over here are both giving me the 150 angle, and when I double it. Okay. What do you think would happen if I replace that 2x with 3x?
There'd be 6 possibilities.
There'd be 6 possibilities. What if I did 4x? 8, and so on. Okay, so let's do one completely unrelated to these two. And then after that, you probably are ready to start.
You have everything.
So let's do, yeah.
So am I right in saying that the B is the amount, the B times 2 is the amount of possibilities there are?
Yes. It won't be 100% of the time, but most of the time. Yep. Okay, guys. If you could go ahead, write this down in your notes, and then let's solve it together. Any ideas what I would do first?
Definitely.
Divide by 5. Sine 3x equals negative 2/5. Okay. What's next?
Visualize your restrictions.
Okay. Oh, I didn't even give us any. Let's do radians this time.
Oh, that's a terrible idea.
Okay. So on my graphing calculator, I would do sine inverse. I'm going to do sine inverse of 2/5. So, but however, this is going to give me the reference angle. So it's not going to give me the actual angle, it's going to give me the reference angle. But from the reference angle, I'll be able to find all angles that have a sine of negative 2/5. So, on your calculator, go ahead and do sine inverse of 2/5 and tell me what you get. You shouldn't get that if you're in radians.
Oh,
Sine inverse.
What'd you do?
7. No. Is that between 0 and 2 pi? Actually, I don't know if there's or not.
Yes. 0.41.
Negative
0.41. Okay, can we go, let's go to 4 decimal places. 0.4.
0.4115.
Okay, 0.41115. So, this is an angle, well, remember this is pi radians. So 3.14 radians, this would be a little more than 1.5 radians. So 0.41 is somewhere over here.
It sounds like 30 degrees.
It's not 30 degrees, otherwise this would have been 1/2. 2/5 is a little different.
It was
than
less
that.
than 100. Man.
Okay,
Maybe it's somewhere in the
so if this is the reference angle, which quadrants have sign that's negative? Which quadrants have a negative sign?
The
3 and
third
4?
and fourth.
3 and 4. So I need to take this reference angle and I need to figure out what is this angle with that same reference angle. How about I do that? Add pi. So this first angle I'm going to do pi plus that reference angle 0.4115. Okay, and don't forget we also have to add any multiples of 2 pi. So 2 pi in. Okay, x equals, what about this one right here?
2 pi minus.
Okay, 2 pi minus my reference angle, 0.4115 plus 2 pi n. Okay, on your calculator, can you tell me what pi plus 0.4115 is?
3.55.
3.55. Oh, I the same thing I did last time. Did you guys catch
Yes.
this? What is it?
You didn't do the x equals.
No, it's supposed to be 3x.
These are all 3x.
Yeah.
That's basically what I read.
Okay, 3x, and then plus, so I'm dividing, no, I'm not yet, okay, plus 2 pi n. And how about on your calculator, 2 pi minus 0.4115?
5.87.
5.87. Yeah. Okay. Divide everything by 3 to get x alone. That gives me 1.18 plus 2/3 pi n. Divide everything by 3 here, that gives me 1.96 plus 2/3 pi n. Okay. So now we write down every answer that works. So I have to make sure x stays less than 2 pi. 2 pi is about 6.28, right? So 1.18 will work. Add 2/3 of pi to that.
And 0.
What's 2/3 of pi plus 1.18?
Plus what?
What's 1.18 plus 2/3 of pi?
3.27.
3.27. And then take that answer and add another 2/3 of pi. What does that give you?
5.369.
5.37. Okay. And if I added another 2/3 of pi, I'm going to be beyond 6.28. So I need to stop here. To move over to this one, do the same thing. 1.96, add 2/3 of pi, that gives me 4.05. Add 2/3 of pi, that gives me 6.15.
That's close.
Yes, I can't add any more, I'll be over. So these are my answers. If I was on a test, there's a lot of places I could have made a mistake. So if I was on a test, I would go back up to this step, and I would take a couple of my answers, maybe like 5.37, try plugging in, I would try 3 times 5.37, do sine of that, and see if I get about -2/5. Remember though, we rounded, so it's gonna probably be within a couple, maybe 100, but it should be super close. Because I would want to be sure I'm getting 100% on the test.
That's a lot of work.
Okay, that's it. Any questions? Yes.
Why isn't it?